Okay, welcome to another Programming in ARM Assembly video series. And in this video series, I want to create yet another general purpose function. So this will be the fourth time we've done this. I created the general purpose print function. I've got a video on that. I created the A to I, the ASCII to integer conversion general purpose function. And I have a three-part video series on that. And then I went the other way around and I created a general purpose integer to ASCII conversion function, and I have a three-part video series on that. So now I want to create a general purpose random number generator. So this is going to be similar to something that I already made in my number guessing game video series, but that random number generator I made in that video series has at least one or two shortcomings that I'm aware of. And I've thought of just a better way to do that in general. So I want to make a dedicated video series just on creating a random number generator. So let's get started here and let's take a look at what we already have. So in the spirit of not wanting to reinvent the wheel, I'm bringing into this random directory that I've created the three general purpose functions that I've already created, which was the print, the I to A, and the A to I. And since this is the fourth time doing this, I'm going to start with a basic shell of a main file so that we don't have to take the time to rebuild this shell. I've already done this, three previous times, so hopefully you've already seen those videos. And then other than that, we're starting with the basic make file. And the make file, of course, just includes the assembly instructions that are necessary to create the .o files, the object files, for the 5 .s files that we're going to be dealing with. So here we have the print that already exists, the A to I general purpose function that already exists, the I to A general purpose function that already exists, and then this will be the new one that we're going to create. We're going to create this random. And then the main.s file, of course, will just serve as a wrapper function, some way to drive this random.s function that we're going to create. And then other than that, at the top, we're just linking all these things together into a single file called main. And then once we're done with that, we're just going to remove the .o files so that every time I run make, it will remake everything. All right, so let's quit out of here. And since we already have the main.s, let's focus on the random.s file. All right, so first of all, we're going to create a .global directive, and that .global directive needs to point to the entry point of our program, which I'm just going to call rand. And then we'll possibly have a data section here at some point. And if we have a data section, that means we also need a .text directive section to indicate where the actual code starts. And the code's going to start here at this rand label that I'm going to create. And then I'll want to have a clear place to exit out of my function. So I'll create this exit label. And then down at the end, I like to put in the .end directive, even though that's not required. And the general idea for the random number generator is going to be something along the lines of, I'm going to need to open a file. And then once that file is open, I'm going to need to save the FD, which is the file descriptor. And then I'm going to need to read from that file, so read file. And then I'm going to need to close the file, so close file. And then once that file has closed, so I've opened the file, I've read something out of it, and I've closed it out. And now at this point, I will be ready to, I can't say I'm generating the random number because the random number is actually going to come from the Linux file system. I'm going to be using /dev/urandom to get it. But what we'll be doing at this point is we'll be essentially constraining the random number so that it fits within whatever constraints we have. And then it's going to be up to me to define, what I want to pass into this program essentially as arguments, and then what I plan on sending back to the calling function as a return. And my plan there, similar to what I've been doing in the previous ones, my plan is to say, we're going to have some inputs of some kind. And what I'm thinking is that we'll have an input coming from our register 0, and R0 must contain what I'm going to call min_rand. And what I mean by min_rand is that is the minimum number that the person is specifying that they want. So for example, if you want a number between 1 and 100, then R0 would contain 1. And then we're going to say that R1 must contain max rand. And of course, max rand would be the upper end of that range. So in the case of 1 to 100, register 0 would contain the number 1, and register 1 would contain the number 100. And if they wanted to change that range to something like 50 to 100, then min_rand would be, or R0 would contain 50 and R1 would contain max rand. So that's the general idea. And then as the output, I'm going to say that we are going to say that register 0 will contain, as the output, register 0 will contain, I'm trying to decide if I want it to contain the random number or if I want it to contain a potential error code. I'm going to say that R0 will contain the error code if there is one. R0 will contain the value 0 if there is no error. So if while running through these open and closed files, for example, if we generate an error, then I'm going to say that when this function returns back to the calling function, R0 will contain that error code. So that's one way we can easily check when we come back from the call. So because we won't know 100% sure that we generated a random number. So what we can do when we come back from this function is we can check register 0. And if register 0 is 0, then according to the promise that we're making here, then we will have successfully generated a random number. So in that case, R1 will contain the random number if there was no error. And then I'm going to say R1, let me actually make these, because I said the first time this will contain the error, so let me actually do these in the other order. R1 will contain the value 0 if there was an error. Let me do it like that, but then let me change the order of these like that. So that way here we're talking about if there was an error, and then here we're talking about if there is an error, and then here this is the case if there is no error, and then here this is the case if there is no error. Okay, so that's going to be like the general outline, the general concept of what we plan to do in terms of handling our inputs and outputs. So before I go too far, what I want to do is, now that I have that file created, I just want to make sure that my make file is set up correctly, and then I can assemble everything and I can link everything. So let me go ahead and test that out just by running make. And yeah, so this is why one of the reasons I always like to do this very early on in the process, so I can catch any potential problems with my make file. Now, I'm not sure if this is a problem. Yep, this is a problem with the make file. I can see what I did. I accidentally put, in the linker line, I accidentally put .s for these instead of .o. So let me go ahead and fix that. Yep, that's exactly what I did. These should be .o, .o, and .o. So let me clear that out. Let's make clean, and let's make, okay. So now we have object files of all of our .s files, and it looks like everything linked together. So if this is currently working okay, and of course we haven't really done anything yet, but we should at the very least be able to run main and then see the exit code of 0, and we can. So at the very least, we have the minimum part put together. Let me take a sip of water. Okay, now my plan for generating a random number, like I said earlier, is to read data from the /dev/urandom file. There's a slight difference between /dev/random and /dev/urandom. Typically, from what I read, from what I understand, /dev/random is a little bit higher quality of a random number generator. But for our purposes here, it doesn't really matter. So I'm not worried about that super high quality. So I'm just going to use /dev/urandom. And I believe the U stands for unlimited, like unlimited random. And the big difference there is just in the way that file needs to be, the /dev/random needs to be locked and unlocked. And I don't know if the underlying kernel handles all of that. But in any case, for this simple, for what I'm doing here, I think /dev/urandom is going to be more than adequate. We can always change it later if we decide. But that means that we're going to need to open a file, read from the file, and then close out that file. So I'm going to refer to my document that I have over here. And we have, for the most part, we have everything that we need to know here in the system call reference guide. However, let me go ahead and zoom in on this to make it very big for the video playback. So even though technically everything is here, it's not necessarily in a really easy to understand format. So I've taken what we have up here, at least the relevant parts for me, and I've spelled them out a little bit more clearly down here. But for the sake of opening a file, reading from a file, and closing a file, I've kind of gone one step farther, and I've made, so this is on reading user input, which I probably won't have to do for this video. But I've, like I said, I've kind of gone one step farther, and for the sake of opening a file, I've kind of laid out all the steps here, because when you're just looking at that system call reference, even if you're looking here at what I have, which is certainly, in my opinion, even more helpful than what we have up here, there's still a few gaps that we have to fill in. So essentially what I've done is I've created sections in this document that explain kind of step by step what's necessary, at least for my use cases, in order to open a file, and in order to read from a file, and in order to close a file. And then I've come down here and I've compiled all those sections together into a single page so that I can make it really easy to follow. And this is essentially what I'm going to follow here. So let me go ahead and minimize that back over there. And I'll keep that as large as I can, but I will have to shrink it down a little bit so that it fits within the window area. But more or less, I'm going to follow what I've already gone through over here, rather than trying to refigure it all out all over again. Okay, so we're going to go into the data section, and I know I'm going to need a file name, and I'm just going to call it file name. And then we'll come over here, and I want this file name to be of type ASCII with a Z, as opposed to ASCII with an I. And then the path to the file is going to be /dev/urandom. And then I know I'm going to need a buffer space, so I'm just going to simply call that buffer space buffer. And here I've noted that this would be type space. There's actually a few options here. What I'm actually going to use is .ds.b. And if you go up a bit farther to this page here where I'm talking about reading from the user input, I have a link here to the sourceware.org/benutil/docs/as.html #ds. If you're curious what that .ds.b is, you can go to that link right there and you can read specifics about what that is. But essentially it's just bit space, and it's specifically bit space that's intended for to hold 1 byte. That's what the .b means, is 1 byte. And I want my buffer size to be of buff size, and I want it to be initialized with zeros. And from my understanding, actually according to that documentation, if you don't include the 0 there at the end, it will default to 0. So that's kind of redundant to have it, but I'm just putting it there to make it clear that we intend to fill that space with zeros. So buff size isn't anything that's known. So I'm going to come up here above the data section. I'm going to create this equality section, or this equivalency section. And I'm going to tell the assembler that when we're talking about this thing buff size, what I really mean is the number 4, is in 4 bytes. Because I want to read 4 bytes worth of data from /dev/urandom. And the reason I want to read 4 bytes is because we have a 32-bit register, and 8 times 4 is 32. So if I read 4 bytes, I'm reading 32 bits. And then we're going to need a file descriptor, and this is just simply an integer. And I don't have to call this .int. I could call this .word or a number of other things, but just for the sake of clarity, I'm going to go ahead and call it .int, and I'm going to initialize that to 0. And on that same page where you use, if you were interested in going and reading about the DS that I'm using here, there will also be information about .int, .word, and everything else. And then if you're not familiar with .equ for some reason, you can also read about that. All right, so let's continue on. So now we've laid out, or I've laid out, the basics of what I need here in the data section. Now I need to define actually how to open the file. And the way that I need to open a file, again, it's all laid out in that system call reference guide, but I've made it much more clear to myself in this section. We need to load into register 0 the memory address of the file name. And currently we already have that file name defined, so we're just loading into memory, we're loading into register 0 the memory address for where that file name is located in memory. And then we need to move into register 1 the way in which I want to open this file. Do I want to open it as read-only? Do I want to open it as write, read-write, and so on? In my case, I want to open it as read-only, so I'm going to say O_RD only, and that's going to get defined as the immediate value 0. So I'm going to do that up here. I go into the .eq section. I'm going to say when we're talking about this O_RD only, what we really mean is the number 0. And then after that, I'm going to move into register 2, the mode. And the mode, I'm pretty sure, is... the mode is ignored when you open a file read-only, but I'm not 100% certain on that. If anybody knows for sure, please do let me know. And then as part of opening the file, we need to move into register 7, the immediate value 5, which I'm just going to say open. And then we'll come up here and we'll define that as open. And I'll put the number 5 there, and let me fix that little mistake. And then we need to do a service call. And service call, I'm going to also define that, is the number 0. So let's come up here, and let's say that when we're talking about service call, what we're really meaning is the number 0. Okay, so that should be everything that is necessary in order for us to open a file. And let me, I like to try to keep these videos in the 15 to 20 minute range. So let me go ahead and close out what we have there. I generally like to close out a video when I have an amount of code that will actually assemble and link and do something. And I think this will assemble okay. But apparently there's a little bit of a glitch in there, but that's fine. I'll go ahead and resolve that glitch in the next video. But if you made it all the way to the end, thank you so much for watching, and I hope you will come back in the next part.